This video is going to be about multiplying and dividing rational expressions. So let's look at the first example. Okay, here we have a multiplication problem. I've got two rational expressions, which are really just two fractions, and I need to multiply them. And you remember what I do when I multiply two fractions is I multiply the numerators and I multiply the denominators. But before I do that, since these expressions, these fractions, are made up of polynomials, the smartest thing to do is to start out by factoring each of the polynomials. So let's do that. This big problem, by the way, is going to have a lot of little steps. Each of the steps is something you already know. So the hard thing now is just going to be to not make any mistakes along the way. Let's see what I can do. I've got x squared plus 7x plus 12. So that's a second degree polynomial. It begins with x squared. So I'm going to set it up like this. My signs are both positive, so I know that the signs in each of the binomials will be positive. And my third term is a 12, so I want the factors of 12 that add up to 7. And I could use 1 times 12, but that won't work. 2 times 6 won't work, but 3 times 4 will work. So now I've got the first one factored. Let's go to the denominator of that fraction. Once again, it's a second degree polynomial, and it begins with x squared. Actually, that's true of all of these. So all of them will get set up the same way. And now let's see. The third term is negative 20. So my signs are going to be different. And I want the two factors of negative 20 that add up to negative 1. So 20 could be thought of as 1 times 20, but the difference between 1 and 20 is not 1. 2 and 10 won't work. Next thing I have is 4 and 5, and 4 and 5 is fine. So I'll put a 4 and a 5. Since my middle sign is negative, I'm going to use the negative for the bigger of the two numbers. And now I'm ready to move on to the second expression. So I want to factor this one also. Also, it's going to be two binomials, both beginning with an x. I've got a negative 14 as my third term. So I could make a negative 14 as a 1 and a 14, but I want a difference of 5. 2 and 7 would be better, because 2 from 7 is 5. So I've got a 2 and a 7. My middle term is negative, so the negative sign goes to the larger of the two numbers, to the 7. And now I've just got the denominator of this fraction. And let's see how I factor that. Signs are negative. Both signs are negative, so I'll have one positive, one negative sign. And my third term is negative 21. So I'm going to make negative 21 with a 7 and a 3, because I want to get to a negative 4. It's my middle term. And that means the 7 is going to be negative and the 3 is going to be positive. Okay, so now I've got a completely factored version of the original polynomials. And now I'm still not going to multiply, because what I can do is I can see whether it's possible to simplify this whole thing before multiplying. Now, when we're multiplying two fractions and we want to simplify first, all we have to do is look for common factors. In other words, if I can find a factor in the numerator that also exists in the denominator, like this x plus 3, I can cross them both out, because they're both going to cancel. I've got an x plus 4 and an x plus 4 over here, so they'll cancel. And I've got an x minus 7 and x minus 7. Well, now it's good that I didn't try multiplying first, because really there's no multiplication to be done. My whole numerator consists of nothing but x plus 2, and my denominator is just x minus 5. So I've got my simplified version. Okay, so once again, all you're doing is you're factoring each of the polynomials, which is where most of the work in this process is. And then you're canceling out common factors. Because basically what we're saying, like when we cross out an x plus 4 and x plus 4, well, that's x plus 4 over x plus 4, and x plus 4 over x plus 4 equals 1. Anything over itself equals 1. So I got rid of this pair that equaled 1, and this pair of polynomials that equaled 1, and this pair, the x minus 7 and the x minus 7 that equaled 1. And then I just take a look and see what I have left. And if there's any multiplication to be done, if there was another polynomial here, let's say, I'd multiply that times the x plus 2, but there was nothing to multiply. So I was just left with the two polynomials, one a binomial in the numerator, a binomial in the denominator. They were different, so I couldn't cancel anything else out. So I'm done. Okay, I want to do another one. I want to do another problem with division, but that's not going to fit on this video, so I'll do a separate one. Okay, see you soon.